Okay, let's continue. I was discussing internal functions. So internal object is any element of a standard set, standard object. So in particular, we consider the set, say C, the set of continuous functions. No, we can consider also C1 and so on, Ck, C infinity. These are well defined sets of functions, say on the real line. Well defined sets. And now we can introduce their non-standard counterparts. So these are star C, star C1, and so on. Star Ck, star C infinity. These are functions. These are the sets which are defined in a familiar way. How to define set star C, for example. Star C is collection of a function f of I such that f of I almost everywhere, and this collection is this set of such function is factorized by the equivalence relation. So two such functions are equivalent if they are they coincide almost everywhere. No, similar with all other things. And from this set we can extract the value of the function. Say if x in star R, yeah. So what does mean x in star R? X, in fact, equals say g of I such that g of I in R almost everywhere. Yeah, no, defined. It is factorized by the same relation equivalence, or we can equivalence two such sequences are equivalent if they coincide almost everywhere. Yes, and now if you are given a sequence of function which is a new function f of I, f element of star C, then if f in star C, then f of x equals the same g f of I at the point g of I almost everywhere. Yes, again factorized by this equivalence, so that two such sequences give the same are equivalent if they coincide almost everywhere. So this way we found what is this? This is also a sequence of real numbers, yes, in the set of such element of such sequence, factorized by our equivalence defined by the ultra filter. So f of x also belongs to star r. Yes, and so f gives us the map from star r to star r. Yeah. So the function f, which initially was this equivalence class of sequences of functions, is in fact defines in fact a good map from star r to star r. Okay, now among these functions we can consider function f of xn, and also can be non-standard, equals say sine n x. So this function is a standard function and can be extended to an internal function when n belongs to star n and x belongs to star r. And f from star n times star r goes to star r. So it is defined as I described before, defined as a good function in between these variables. And now I wanted to discuss the following question. What is standard part of f? We know the notion of standard part for numbers. So for any bounded non-standard number element of star R, we defined a standard number which is called its standard part, such that this non-standard number is infinitesimally close to standard number. Yeah. However, it is not enough. I want to define what is the standard part of every object of our non-standard universe. Yes? So, know what is standard part of f and what is standard part of any relation, any function, any set, everything. Yes? It is universal thing which works everywhere, and it saves a lot of work because why is it so important? No, there is a philosophical attitude to non-standard analysis that it in principle gives nothing new, does not increase our knowledge of anything, because all the rules of non-standard analysis by the transfer principle correspond to facts from standard analysis. Yes, and so it sometimes maybe it helps to have some information, standard information using non-standard way, but in principle it cannot give anything new. This is because we are working in the realm of internal objects, internal sets, internal relations, internal functions, and so on. If it were true, then there is no, use of non-standard analysis, and it does not deserve to be worked on. But fortunately, this is not true. It is simply not true. Because we have important external objects in non-standard analysis. So external relations, external predicates, for example, predicate finite or infinite, are external, as well as infinitesimally small. It is all external things. Yeah? Standard part is also external. If you recall how we defined the standard part, it was done using external tools, which are not contained in the non-standard analysis itself. Yeah? By the way, any manipulations with the language, with the formulas of the language, are also external. Yes, the language itself is outside of analysis. It is not the object of analysis. Yeah? If we permit it to be the object of analysis, then we immediately have a snake which bites its own tail. Yeah, and we'll have different things which are important, but it's dangerous domain. And this is the intermediate between this non-standard analysis and our standard world, which and this intermediate is not internal, and this means that it brings a new content. Yeah. I hope to show you somehow that new objects, new I would say creatures are created in non-standard analysis and brought into standard universe, which do not exist there, did not exist before we did it. Yes, so it is purely a creative thing. Okay, so let me proceed with the definition of standard part of any object in non-standard universe. For any x in star u, we define standard part of x, which is element of u, of our standard universe. This is what I am going to do. So what is standard u? U equals U0 union with U1. Let me write this way. UN. It is the union of different levels. U0 is made of individuals. So individuals are not sets. For individual, it makes no sense, or the same, it is always wrong that something is element of this individual. U1 equals U0 union subsets of U0. U n plus 1 equals UN union the set of subsets of UN. Now, no, it's no need to follow again all the steps in construction of non-standard universe. We have that star U equals union of star U k, k from 0 to infinity. Now again, star U 0 is made of individuals. What does mean is made of individuals? Star U0 is made of equivalence classes of functions on the index set. Yes, so there is a lot of things to do. But simply we defined the inclusion of elements in this non-standard universe so that there is no elements which are in this sense included in our into our element. So in this new sense are individuals. U k plus 1 is a subset of star U k union P of star U k. Simply because P of star U k is too large. It contains external sets as well. And this universe is made of internal sets. Yeah? K equals 1, 0, 1, and so on. So we defined this. What is U0? No, in general, U0 contains not only real numbers. It can contain different things. For example, it can contain points of some space, say metric space or topological space. It can contain, if you wish, elements of Hilbert space. Again, it depends on what we are studying. So these elements are all individuals, and correspondingly we have star U0, which is also made of individuals, and this set can some of its elements can have real part and some do not have. No, for example, if you have a real non-standard real number, then if it is infinite, then it has no real part. Yes, so real part, no standard part. Standard part is defined not for all of them, and similar for other possible elements of star U0, for example, elements of non-standard Hilbert space. Some of them can have real part, have standard part, some have none. So let it be. Yes? And now, so anyway, I assume that standard part is defined for all elements of this zeroth level, star U0. And let us go farther. So standard from star U0, it maps to U0. This already is defined. Now I wanted to add one comment which is maybe important. So among other elements of U standard universe, there is one particular element which is really singular. Namely, it is the empty set. Let us consider empty set. Is it individual or is it a set? Yeah? So, if X is individual, in U, then it has no elements. This means the following is true. For any X in U, any Y. It is not true that Y is element of X. Yeah? So this formula shows us, it says us that X has no elements. Yes? But this formula is also true for X equal empty set, because by definition no element, no Y is element of empty set, because empty set has no elements. Yeah? Yeah, so so if you substitute here empty set in the place of X, you will have a true statement. So this means that formally empty set is individual. It is called set, but it is individual by its properties. Yes? There is also, so this empty set has a double nature. On one hand, it is a set. Yeah? So in this sense, it is a subset of any set, and as such is element, it's present at every level of this hierarchy of sets Ui, Uk. Yes, on one hand. On the other hand, it is individual, so it presents also on the zeroth level. Yeah. So let us put this empty set. Okay, for all k, 0, 1, and so on. Yeah. So empty set we will regard it as individual when necessary. No, okay. And now we will define standard part of any object in our non-standard universe step by step recursively. So suppose standard part of X is defined for all X in star U n. It is already defined. So we want to define it for star un plus 1. Standard of X for all X in star U n plus 1. So how to do it? Let us star U n plus 1 is a subset of star U n union with P of star U n. Yeah, as we already, it is by definition. So if X in here, star U n, then standard part of X is already defined. Yeah. So assume that X in P of star U n. Yeah. So X is some set, its elements of this set are elements or sets of star U n. Then define standard part of X equals union sigma of Y for all Y in X. Yeah. So Y is star U n. So what is sigma of Y? It is set of Y, standard of Y if Y if standard of Y is defined empty set otherwise. No, for example, if our U0 is just R, so we are all our universes constructed starting from real numbers, then what is U1? So U0 star U0 there consists of finite or and infinite non-standard numbers. So sigma of y is a standard part of number if this number is finite or bounded, or if it is unbounded, we write just empty set. Yes? So if you have some set of these non-standard numbers, what will happen? If you look at this formula, you have to take any member of this set of hyper-real numbers, yeah? And if they have standard part, then they will be added to this new set. If they have no standard part, then nothing will be added, because otherwise it is empty set. Yeah? So we have just the set of real standard parts of the numbers which have this standard part, nothing unusual. This way we go further and further, step by step. So this is a definition which works universally. That's it. No, okay. So now I wanted to move next step closer to function. So this way I defined a standard part of x for any axis start u n plus 1, yes, and then go next step to start u n plus 2 and so on. So this way we really define it. Is looks like a simple construction, but let us look how it works in our case. So consider the simplest case. Standard part. So we have two elements A, B. We formed a pair of them. It is a set. So if A and B are somewhere on UN, then this is element of UN plus 1. So by definition, equals sigma of A union sigma of B. Yes, because it's written here. And what is this? Equals, if A and B had standard part already, then it is just standard part of A, standard part of B. So it is the pair, the set of two elements which are standard parts of them, nothing unusual. So if B are defined. Now otherwise, if say standard of A is defined and standard of B is not defined, then you have, or it's say A no it's A union, which is equal to A, if standard of A is defined and standard part of B is not. Yeah? So in this case, it will be just A. Or it is empty set if standard of A, standard of B are not defined. Yeah. Now, what is standard part of ordered pair AB? So what is ordered pair? No, by definition, standard part of a report, it is the set A, the set AB. Oh my God. So you have a set whose elements are two sets. Now, standard part of one element set A is, let me write, it is the set sigma of A sigma of AB. So this set of two elements. Now again, if standard part of A is defined, then what is one element set A? It is in fact pair AA. Yes? So the result will be the set whose elements, sole elements is A. Yeah? No, let's assume that everything is defined. Standard of A and sigma of AB is the only set whose elements are standard of A and standard of B. And this is just the pair standard of A, standard of B. So this way we introduce, yes, otherwise if one of them has no standard part, then one of the standard parts is replaced by empty set. Nothing more. So if standard of B is not defined, then we get a standard of A and empty set. No, you can look at more closely yourself. Now, if both are not defined, then you have empty set, empty set. Yes. Anyway, this empty set is a subject which is responsible for all cases when something is not defined. Hmm? Because it has no members, I think it will suffer immediately. I mean immensely. Okay, now let's consider the function. From standard R to standard R. No, some function standard C. Yeah. So consider the function which belongs to standard C. So it has a meaning from standard R to standard R. So F is a subset of the Cartesian product. Standard R times standard R. Yeah? Let's graph of this function. F is the set of xy belonging to standard R times standard R such that y equals f of x, x in domain of f and y equals f of x. To be complete, f is this is a set. Now what is standard f? Standard f by definition is union of sigma xy such that xy elements of f. So standard part of f. And sigma of xy equals the union of the following thing. We have to take all xy in our graph and take their their standard parts, because we already found that sigma of xy is sigma of xy is either standard part of this or empty set. So it is standard part if x and y have standard part. It is the set standard of x, standard of y. It is this. It is union for all xy, xy in F, and standard of x, standard of y do exist. Yeah. So otherwise it is empty set. So empty set, and with union of these sets and empty set doesn't bring you nothing new. And this is simply standard of f equals the set of standard x, standard y, such that the pair xy in f and standard x, standard y are defined. Yeah, so after all, we have this. No. Okay. And now with this knowledge, let us consider our function. F of x equal sine n x. F from star r to star r and star n minus n. So n is infinite. So this is this function. So what is star f? It is the set of standard parts of x and y. No, the value of this function for any finite, for any x, is between -1 and 1, because it is true for finite n, and so by transfer it is true for infinite n. Yeah? So, this is so this means that the value of the function y is always has standard part, and so we need to have it standard x standard. This means that for some C in R. R plus. So this means that this means that x should be bounded, and only for this we have to define this pair, standard x, standard y. So if you have x in star r, model x less than c, so it is bounded, then we can consider its how it is called, infinitesimally small neighborhood, which is called monad. Consider a monad of this point, x. Yeah? And consider the set of the points say x prime is between x and x plus 2 pi divided by n. Here n, this n, infinitesimal. Yeah? So this interval or segment x plus 2 pi divided by n, this is infinitesimal number, 2 pi divided by n. Yeah? And this means that it is all contained in monad of point x. Yeah. So this means that standard part of x equal standard part of x prime in this segment, on one hand. On the other hand, so it corresponds to one and the same point after you take standard part. On the other hand, standard part of f of x prime so x prime goes from x to x plus 2 pi divided by n, and n times x prime changes within period of length 2 pi. And so within this period, function sine takes all values from -1 to 1. Values from -1 to 1 as x prime changes between x and x plus 2 pi divided by n. Yeah? And so what we see, they see that all points standard part of x, y between -1 and 1 are in standard part of f. Yeah? No, we can take standard part of x any because we take x as standard number. Yeah. So, and we can conclude that standard part of f equals the set of all x, y, such that x in R, y in -1, 1. Yeah? So, the, so to say, graph of this function is all this strip without any gaps. Yeah? It is, so the graph of this function is not only everywhere dense here, but it simply fills it all. Yeah. Okay. Yeah. Now, similarly, we can consider the function gx equals 2 divided by pi arctangents and x. Again, with n infinitely large, yeah, so g from star r to arctangents of nx for finite n changes 2 divided by pi between -1 and 1. So this remains true for all infinite n. -1, 1. Yeah? And again, if x different from 0, then no, okay, if is more than 0, then this function g of x is infinitesimally close to 1. If a standard part of x less than 0, then standard part or not of x of f of x. Not x. Then standard part of g of x is infinitesimally close to -1. If x is itself infinitesimal, yes, then standard part of g of x can take any value between -1 and 1. Can be anything between -1 and 1. And so we have the following beautiful picture. So g of x here is g of x here is 1, here it is -1, and also we have to add this vertical segment. Yeah? So this is the standard part of the function. No, if you identify function and its graph, so it is a standard part of the function. Or if you wish, graph of standard part of the function. Yeah. So when you take standard part, the function can cease to be a function in usual sense. It can become multivalued function. Now the last thing, the last example, let me consider. H of x equals square n 2 pi e minus n x squared. So it's a Gaussian function, and again n is infinitely large. So in this case, we can see the following, that if x is any non-zero number, then h of x is infinitesimal because of this factor which overweights this factor. Yeah? So this means that the function for positive and for negative x is a standard part of of h. This function is 0. Now the value at the point 0 equals square root of n divided by 2 pi. You know, if n is infinite, nothing wrong. It's a good infinite number. But arbitrarily close, I mean in the infinitesimal neighborhood of 0, this function can take any values from 0 to infinity. And this means that in this case, you have this picture. All this vertical semi-line is a standard part of this function h. Again, we have the loss of uniqueness of the function value. No, okay, so I spent a good deal of this lecture on the definition of general standard part. Why? Because we will use it in many other, no, as many as we can, examples and applications of non-standard analysis, and this will give sometimes surprising results. Okay, you know what? I wanted to tell something else today, but it is a new topic that would take a lot more time than we have. So let's finish today on this, because otherwise we'll have to spend another 2 hours. So next time we will continue. Okay?
Thank you.